Hello, Mr. Allo.
Hi Gaurav ji.
Can you please allow me for sharing my screen? I don't have permissions for that.
I think you should be able to do it now.
Okay, yeah, I can do it now. Okay, fine, thank you. So, are you able to see this flyer? Okay, captioning is online.
Yes, Gaurav ji, we can see your screen. Can you put it on full screen? नहीं, if you go below, नहीं इसमें नहीं है. आप अगर
This
वापस
is PDF actually, no?
व्यू में ही अगर आप आएंगे,
अच्छा.
फुल स्क्रीन हो जाएगा यहाँ से. Click on view on the top.
Just a minute. Yeah, so view, where is that?
आप आई थिंक PDF में नहीं है शायद, अभी कहीं और है आप.
नहीं, I'm
Yeah,
not
on the top on the view. Click on view.
I don't see view here. Zoom application is open.
Okay, because
Just a minute.
I see your screen right now.
Okay, view here. View is there.
Yeah, and it says a full screen.
First, okay. Okay, just a minute. Let me share. Okay. Okay, fine. How can I mute and mute? Okay, fine. Okay, so I welcome you all. Am I? So I welcome you all, the participants on behalf of IIT Delhi Build-a-Thon team. So this is roundtable 2 of Build-a-Thon 2022 ITU AI/ML challenge. So this is the flyer that you can see. So the as a part, so in about this roundtable, we'll be touching upon the topics about the problem statements, a brief about the MEC testbed, about the data sets, and the pre-evaluation, which is just coming up on 29th of September. So, and of course, we'll be have an interactive session with the participants, and we'll take up their related queries about the topics mentioned here. So now I'm sharing so I think some of maybe I'm expecting some new joinees here. So for this sake, I'll go through the landing page. So just a minute. So this is our Build-a-Thon landing page. So you can get all the highlighted, these marquees are there, there's floating text that you can, all the latest events will be posted here. So besides, these are our stakeholders, these are the parties that are involved here in. So Indian Institute of Technology, Delhi is the technical and management team. Telecommunication Standards Development Society India and TSDSI is supporting partner. ITU International Telecommunication Union technical partner. India EU ICT Standardization Collaboration Project is funding and supporting the Build-a-Thon with experts from EU and award for the winning team. Okay. So this is the overview of the this Build-a-Thon. We can go through it. Besides, this is so these are the problem statement. There are two problem statement mentioned here. So one is slip detection along with the force detection, and one is problem statement two is the object detection. So you have to get this is about the object to define the what kind of object you're holding. So this can be I'll our technical team will take this up later on. Problem statement and data and statements. So this is events and announcements. This is an important section. So always all the party, I request all the participants to go through this section. I mean, once in a day or twice in a day. So that all the important information will be posted here besides the emails in their emails also. So this is the coming event 29th of September. That is pre-evaluation of the solution. So this is lined up quite and very close to and this 11th October is the final submission. So I mean, always remember these dates. Then coming to this is the this is for new participants. Those who want to register can register from here. So and there are some past events, the recorded events are there. So for problem statement one, sample data set is there, and for problem statement two, training data set as well as sample data set, both are there. So you can download and train your, for problem statement you can download and train your model with training data set. For problem statement one, the data set will be available in a day or two and will be mailed to you, as well as will be posted in the this landing page here also. So you'll be informed about it. So pre-evaluation, we have all the participants are requested to submit their model solution on 29 September 2022 for pre-evaluation, and the results will be reported in a couple of days. So your model solution will be tested on the validation data set provided by our testing team. So on 29th, we'll open a window for a few hours and we'll providing you the data set for value, and you have to give the results on the data set with your trained models, and all the important aspects of will be mentioned to you. So this activity also has a weightage of 20% and counted towards the final result. So don't underestimate me. I mean, it's 20% of the your overall evaluation. So take it seriously. And later on we'll post the teams in the leaderboard, so their respective positionings in the contest, so that you can evaluate yourself where you are standing in the contest. So this is it. These are the events and announcement is an important section. Always go through this, and then I'll be telling a brief about the MEC testbed. So MEC testbed. So IIT Delhi has developed a MEC testbed integrated with 5G code confirming HC standards. So in the last 3 years project, we have developed this testbed, and it is also integrated with the 5G core developed by CIVIT and IIT Bombay. So and we have developed some application to run over it. Also this haptics application. So we have a haptic application with the actual hardware that is running on it. And we have tested with the APIs also. So I'll be giving a brief introduction of about this test bed is, and then So let's have a brief introduction about this thing. Okay, so So this is so let me introduce you with some concept of what is MEC. MEC means mobile edge computing. Actually, it is multi-access edge computing. So suppose there is a UE is connected to one of the cloud server here. So that green line shows this cloud server. So it goes through via a radio access network to the core network, to the external network, and to the cloud. So I will be multiple hops. There are a lot of there is some latency involved uh, in it, and so what if we have something very close to the radio access network, that is so we bring the part of the server, or the full server can be moved to the near to the radio access. So now UE is connected to something very close to this tower, this radio access network. We in 5G core we call it G node B. So all the data that was going all through this path is now via this radio access network going directly to the mobile edge cloud server and mobile edge server. So all the between client and the interaction between the client and the cloud is reduced to the client to the mobile edge computing server. So this is the concept of it. So we call it a near server. This is the concept of this edge computing. So it is, I mean, for latency centric applications like haptics or computation offload, if you want to do, we can do it at the edge, and that path is already open for up to the cloud. Besides data coming to the cloud, it is also going to the edge server. So these are the HC. So I'm just skipping this thing. So these are the proposed architecture by the MEC. You can go through it on the internet. And what we have a testbed here. So this testbed have all the components of 5G core, RAN emulator, which is a combination of this G node B emulator and UE emulator, and ULCM, MECO. These are part of the MEC system. And then we have these edge server at the HDNN. So we select one of the edge server to perform this computing at the edge. So client connects to the cloud, and once the application the traffic influence traffic is transferred to the host, the client connects to the edge applications here. So basically your haptics will be testing this haptics application, whatever you have developed the solution on the actual hardware on this testbed, and this will be tested upon. And so, but still I insist that you need not worry about this system or something, because this is the abstraction is done absolutely well. So, and we are running haptics applications over it, and we don't have anywhere also, because everything basically boils down to this client app, this cloud, in the cloud server cloud app, and the MEC app. So this is basically very easy with some configuration files and little changes, and IIT Delhi Build-a-Thon team is there to help you with this thing. So, and then, so basically the application deployment is like this way, but you only have to think about the application deployment. And the way you are doing it, do it the way you are doing it, that you're developing your application, and later on it will be hosted here in the MEC testbed. So already we are running this haptics application with actual hardware. I say that with actual hardware, we are able to do this edge computing. I mean, with the edge server interaction with the edge cloud and at the UE level. And we have other applications also running. So I think this is the so now I'll hand it over to our technical expert Munib. He's a PhD scholar here, and he is handling all this haptics related issues and developing. He's still doing his research on it. So I call Munib to please take the podium and touch upon this problem statement and data sets, and then can take up the questions from the participants. Thank you.
Good afternoon, everyone. So I'll take some of your time. I'm aware that there are some new participants. And for this, I'll quickly recap through the problem statements and tell you what exactly the challenge is about. So let me quickly share this screen. I'm audible, right? I'm audible. Somebody has to confirm, right? Mr. Alok, am I audible? We hope that. Okay. So, so the first problem statement of this challenge is that so there is a robot that we have that is trying to pick up an object of interest. Okay. And given that that object is currently held by that robot, so we have already talked about what kind of robot we have and all those things. So I'll quickly let you go through the data synthetic wave of the problem statement. So now the first given is that the object may tend to slip from the grip, right? So that means that object is currently being held by that hand or that robot, and it's tending to slip. Okay, it's a control slip environment. That means we are inducing that slip. And now what you will have to do is you will have to find if that object is trying about to slip. Okay, so slip here refers to some kind of an act of gravity, or that object is not being properly held by that robot. And now you'll according to the data that you have available at that point in time, now you'll have to apply appropriate control in order to prevent that slip from happening. And while doing that, you just have to make sure that the object does not break. So as in the definition of this problem statement, now you might have got an idea that there are objects that might be deformable as well. So given that those objects are deformable or not deformable, and those objects are trying to fall from the grip of the robot, or not fall, and then you'll have to use an appropriate estimation technique to determine the force that effectively handles that kind of an object. Now, let me quickly go through the data set that we have. I think we have, so we have a sample data set. Let me open it for you, and then we'll tell you what kind of a data you would see there. So let me save it. It's not visible, right? It's visible. The participants would have to be sure about. Okay. So it's visible, right? So I'm just. So if somebody can confirm that it's visible, so then you would see that there are, it's not visible, no? So that's what yeah, so got that. That's why I asked. So what is this? This is not the point. So somebody will have help me in these things. Yeah, sure.
यहाँ पे stop share. Share a screen with. You can share show all windows.
There is screen share. Follow the screen share too.
Yeah, this is show all windows.
Okay.
No, the screen, screen you can share.
Okay.
Board, I think. Okay. Yeah, I think.
I hope the screen is visible now. So this is the kind of data, sample data that we have here. So yeah, so this is the time series data. The robot that handles that object has some encoding points. We label them J0 to J15. So there are 15 joints that the robot has. So on those encoding points, it records two things. One is the angle that joint is holding that object, and the force that it experiences while handling that object. Now, on in correspondence to this, there is the weight of that object being held, and going through the time, picking it up, and so on and so forth. So there is a label whether it's slipping or not slipping, and there is a crumple label. So that means whether the object is being crumpled or not. So in this case, while handling, let me be very discreet about this kind of a data point. So this means while having this angles and this force, the object is the object's weight is 1 kg. The mass is 1 kg. Sorry, this must have been mislabeled. So the mass is 1 kg and the object is slipping right now, but it's not crumpling. So that is what this data point essentially means. While going through the time, there is another object. Obviously, in this case of scenario, we'll have a continuous time series. So this is a sample data set. Only one data point has been effectively shown here, but otherwise you would get a continuous stream of such data points while handling that kind of an object. So I hope I am clear with this. Let me now go to the problem statement number 2. So yeah. This was right. Yeah. So the problem statement number 2 effectively tells you to determine the shape of that object. So in that case, we have some 13 or 14 different types of objects. They are being held by the robot. So that's another given in this problem. So that's held by the robotic hand. And now that robotic hand records its current states, the states similar to what you saw in the previous data point. That essentially contains angular configuration and the forces exerted on those joints. Now, using these data, should I say, samples, you will have to determine the shape of that object. In this case, the data set would be something like this. Let me download it for you. So I'll download a sample data set. The training data set contains the same information. So let's stop. This has some. I'm sorry, so somebody has it.
Why are this thing? Where is this? This. Okay. So
yeah.
Is this no, this is sample boxes. This is task.
So task 2 that deals with object detection. Let me open it for you. Let me just confirm that is data set. This is not, so let me close it. It's okay. It's okay. So this sample data set also contains the joint angle configuration of the forces as similar to the previous problem. Apart from detecting slip end, I mean, other than detecting slip end, this problem deals with only determining the shape of that object. So in this case, we have 13 or 14 different, I guess 13 objects labeled as cube cube A, cube B, cube C, you'll have to see it in actual training data set if they are labeled cube 1, cube 2, and so on, or cube A, cube B, and so on. So there are 13 different types of objects. There will be a mass associated to each of the object and this data sample. So given that this data sample at a particular instance of time, you'll have to determine the type of the object. Yeah, sure.
You mentioned the different kinds of cubes.
Yeah.
So if you are just mentioning the weight
Yeah.
of the cubes.
Mm.
So what about the dimensions?
We are not,
Will-
no, so we are not defining. Okay, so we have a good question here. So the question is that we have the shape of the the dimensions of that object as a parameter, right? So we don't have that.
How do you judge that they are of different cubes by?
Correct. So this is where the modeling approaches will come into existence. So basically, other than obviously you can determine the object type on the basis of its dimension, right? We don't want to do that here. We want to the intuition here is that without using any vision ability, given the forces that are exerted on that robotic hand and the angle configuration on it, what is the shape of that object?
You are
So-
only focusing on the shape of the object.
Yeah, or the type of the object. We're not even asking to determine the dimensions of that object, right? So
So then how will we differentiate that this is the particular kind of cube that only differentiate through weight only?
no, obviously when there is weight, there is dimension change also. Okay,
So we have to.
you'll have to learn that dimension change, right? So all the cubes are made of same material, right? But their weight is different, so their dimensions are different. Okay, sure.
So how is the time series playing
Uh, there is an intrinsic characteristics in that. Yeah. So, yeah. The question is that how is that data time series able to determine that kind of a shape, right? So while you hold a ball, you hold your hands differently, right? Let's say you hold it curved, something like that, right? While holding a cube, the thing would be slightly different, but it will be different, right? While holding a pen or something like that, right? So the shape of the angles of that robot will be different. So the angles will determine the shape of the object essentially, right? So the forces might be used to determine the mass of that object or something.
But for the same type of object, the time series might be similar if they are not changing the.
Yeah, but essentially it would not be so similar and it would not be so different. Okay. Yeah, but for two different types of objects, this will be definitely different. Okay. Okay, so I hope I'm clear with this. All right, so this is it. The next thing that I want to talk about is yeah, so we have recently got some questions related to the system approach of how we are doing the things, like access to MEC test bed or something, right? So the participants don't have to worry about how the system is working. Obviously, the code, your code or models will be tested on that system, but you don't have to worry about that. So you'll have to keep your approaches extremely data centric. So whatever modeling approach you do, you just look on the data and try to formulate a model that essentially does the work for us. And the next thing that I want to talk about is the submission instructions. So we have formulated some submission instructions, and we would post it on our website, I think today or tomorrow. And there will be a proper guidelines as to how your submissions should look like. On the pre-evaluation day, there will be a validation data set that you'll be given those validation data set for each of the problems, and minus the label. So essentially, let's say that sample data set. Let me open it for you once again. So we have come to a conclusion that we'll provide a validation data set to you in this format. So the validation data set will almost be similar to the training data set, except the label. So we'll give you the data set, except the label, and you'll have to tell us what the label is. So your submissions would something look like a CSV formatted file or something that you would submit to us, then we'll evaluate that. So this is about the validation part of that pre-evaluation. Now the actual submission, the code we have, the code instructions and all those things will come up on the website very soon. I think you'll have to stick with Python 3.7 or something, but the exact instruction will come on the website only. And Yeah, that's it from my side. So I'm ready to take up any questions if you have. So, yeah, just let me know. Sure.
So, while building the model, what is the improvement? Like it should be.
Yep. So yeah. So exact evaluation criteria will be told very soon, but I would like to tell you that the model should be latency aware. Okay. So the prediction time should be very, very less. Okay. So this is a generic criteria, right? Okay. Exact criteria like how accurate your model should be and all those things will come up soon. Okay.
So we could use any library.
You are free to use any libraries. Okay.
And we need to register only for one problem statement.
I think from somebody from management will answer this question.
You can do both.
So the question is that how many registrations they have to do for. So the question is that there are 2 problem statements and how many problem statements do they have to register for? So the answer to this is that they will have to do either one or both. Right? And they would be evaluated individually, right? Yeah. So if I have any other questions on the chat box or something.
Yeah, we go to chat on.
Okay.
There's a puzzle for the request button.
Okay. So yeah, just over to you, Vinthana. Thanks.
Thank you so much, Mani, for that. I will tell you later on, say thank you to you for the amount of time and devotion you spent on the data set. It's really tremendous. Done almost around 10,000 rows, I think. And he's got another data set also coming up. So it's a huge amount of effort which Munib and his team have put in. Not his team, actually, he's the only one and was concerned. Of course, Professor Arzad is online. Professor Arzad, if you don't mind, Professor, on behalf of Professor Lal, can you speak a few lines?
Okay, so yeah, thanks, Mohammed. So good afternoon, everybody. So I'm not in the best place right now. We will be having.
Professor, we can't hear you. Could you just speak up, please?
Yeah, I'm in a lab and there'll be a lot of background noise.
Okay.
There's
Fine.
a lab going on, so.
No issues, Professor. We will just continue over here. We just want to thank everybody and also encourage all the students over here. Even those, I think almost everybody is now exposed to AML problems, but even those who are not, please go ahead. Especially problem statement number 2 is comparatively a simpler question, and you should participate in that. There are, you can write emails to us, to the staff sitting here, and they will ensure that you get answers, and you can also learn a lot in this process because we have Professor Brajesh Lal, Professor Arzad, who are leading this whole thing. And we also have a number of mentors. If you need a mentor, if you're registering and your team needs a mentor, please do let us know. We'll get more faculty in who are very interested in participating and mentoring. So please let us know. They will mentor you and you can put up excellent solutions. This is actually a real world solution on a test bed, which is actually there. So, and you're also invited to come to Bharati School and have a look at the test bed, which is put up. Almost 3-4 years of effort has gone in by Gaurav and his team, Professor Arzad's team, Professor Lal's team, in putting up this and coding this complete setup of almost around 5 or 6 different virtual machines, you can call them, non-virtual machines, whatever, but they're all set up in a multi-access edge computing setup. And this is what is going to enable the haptics low latency for you. And finally, the winning team is going to actually, their solution, their model will be put up on the MEC testbed. And it will be there for everybody to see. So I would just quickly run through the thank yous. We have never thanked Professor Brajesh Lal and Professor Arzad, especially because they have mentored and they have actually designed, created the problem statements as well as the data set which Mr. Munib is working on. Excellent job they're doing on that. And then we also want to thank Mr. Vishnu from ITU TSDSI, who has aligned us to the ITU Global Challenge, because this is a regional challenge. It's like an ITU regional challenge, which IIT Delhi is leading for this particular region. And Vishnu is actually guiding us on that. He's also from TSDSI. And then, of course, finally, we have Mr. Gaurav, of course, is there on the MEC part. And we have This one, yes, of course, India, EU, ICT team, how can we ever forget them? They are there supporting the challenge, and the awards will be given by them. They are the ones who are going to be sending the winning team to you finally. And you can actually go for study tours out there, have a look at similar setups over there, and also work with Professor Lal, with Mr. Muni, Professor Azad, Gaurav, and set up your model on the MEC testbed out here. Is Professor Brijesh line online? Can you just see? Professor Lal. He's got a meeting going on. He wanted to join in, but he had something. So if there are no more questions, nothing on the chat. Okay, I don't, please feel free.
Ask them to, whatever the query is,
Yes.
like to be bothered and just.
Yes, yes,
whatever
please,
they-
please feel free. Whatever little question you have, whatever little issue you have, whatever little, you can please put it up and on email to us, and we will get a reply. We have people sitting on the side. We have mentors for you. Please learn. Use this opportunity to learn. If you don't want to win, fine, but please learn. Everything is there, and your solutions can actually run over here, and you can see what results you're producing on the low latency side. I think we can
Ma'am?
close the session. Yeah.
Ma'am, I have a question for Munit sir.
Yes.
Hello sir.
Yeah, hi, so please go ahead.
What's the exact use of simulator here, the pipelet you have recommended?
What is the exact use of simulator here? So yeah. So the data that you are seeing is that about those problem statements, we have collected that data through a simulator. So there is a robotic arm and then a robotic hand. Robotic hand is mounted on top of a robotic arm, and it's trying to pick up an object of interest. So the data that we have collected is through that simulator. So that is the exact use of that simulator. You don't have to worry about how that simulator works, right? So,
So we can also use to validate our model in simulation.
you are welcome to use that simulator. You just we could just give you pointers about how where to download that simulator and all those things. Rest of the things, if you want to simulate that robot or simulate an object or something, you'll have to write that code on your own. Obviously, that does not have to deal with anything related to this challenge.
Okay, got it. Thanks.
What would be the timeline for the validation, like when the we looking for solution to it?
Okay.
Because we have minus 28.
Yeah.
Essentially just.
Okay, so the question is that how much time will the participants get in submission of the validation data set? I think somebody from management will have to answer this.
We will be following the ITU global timelines. That is why we have restrictions of having your first pre-evaluation coming on 29th of this month. And then on 11th, you have to give your final submission after they release the validation data set, final, because actually on around 14th, we need to submit it to ITU global, because your winning entry will go into the ITU global. That is why we are following the timelines. It's not in our hands. We can do maybe a day or two here if we get a lot of requests coming in, but not too much.
Yeah, so essentially the deadlines will stay on 29th end of day, means midnight. Yeah.
And how many submissions?
You can make as many submissions as possible, so that's not a problem.
And for the final submission, we could change the model.
Obviously, of course. So the first submission does not have to be submission of your code. Okay. First submission will give you a validation data set. The validation data set will be similar to the training data set. So those will not contain labels. So you just have to provide us the labels of that set that we do, right? But in the final submission, you'll have to submit your code. Does it make sense?
Yeah.
Okay. Any other question that anybody would like to ask? Do we have anything on the chat box? Okay, so I think we are done here. Thank you for joining this meeting. This was lovely interacting with you. Thanks so much.
We look forward to your replies. Please reply on email. And thank you, Miss Chaiti. Yes, very interesting questions. I hope you get even your friends also excited about this. All of you should join in. Yeah. Thank you.
Join an existing team because
JT is asking, is it possible to join an existing team? So for that, we will request Mr. Gaurav, we will coordinate with some teams who have lesser number of people, and we'll just find out if, JT, just send in your a short little profile about yourself to Gaurav, and he will then try to connect you to a team.
Yeah.
So maximum allowed are 4 members. In case there are lesser numbers or you're a single person and you need a mentor, please ask. I will definitely team you up. If not, you should definitely join in alone, or we will get you some team members. Not an issue at all. Thank you. Thank you, Mr. Alok. Thanks a lot, Mr. Arun. We are ready to sign off. Thank you.
Okay, thank you. I'll just start it off then.
Yes, please. Thank you. Bye.
Okay.